Okay, this is your third practice paper class for your upcoming assessment. Honestly, this will help you so much. The skills will be the same as 80% of the skills that you'll need to do well. So, question 1, we should be excellent at this. We just add the powers. It's a 1 marker, so you can just write the answer down. That's w to the power 12. This we subtract the powers. That's t to the power 6. Right, question 2. We're solving. It's 2 marks, so you don't need to have too many lines of working out. You do need to subtract the smallest amount of x. So I'm going to minus 4x here. So I'm going to get minus 13 equals 17 plus 4x. I like to keep the x's positive where possible. I'm going to minus 17 on both sides now. So that's going to be minus 30 equals 4x. So x equals minus 7.5. Question 3, it says show that. The best way to show that is just to work that out. So let's turn that into improper fraction. 5 times 3 is 15, add the 2. So that's 17 over 3 minus 8 plus 3 is 11 over 4. We want to make the denominators the same, so I'm going to times this by 4. And this by 3. Uh, 17 times 4, 40, it's 68 over 12 minus 33 over 12. It's going to be 35 over 12. That's good. So that's the clue here, because it's something over 12. Yep, 2 12s go into 35, and there's 11 left over, and that's your 3 marks done. 4. Right, that may look confusing to you, but you just multiply. When it's in brackets, you just multiply the powers. So 12 times 3/4. So what you're just doing is 12 times 3/4. The easiest way to do that is divide that by 4, then times it by 3, which is 9. And that will be y to the 6. That's a nice easy 2 marks for you as well. Right, question 5, you've got a set of numbers here. A is all the even numbers. So let's just show you. A is all the even numbers. That's 12, 14, 16, 18 and 20. B's are multiples of 3. So that's going to be 12, 15 and 18. Right, that means what's in A and B of those sets of numbers, so that's just 12 and 18. And A or B, so that's 12, 14, 15, 16, 18 and 20. Now you should have 1 extra. 1, 2, 3, 4, 5, 6. And there's 5 there, that's correct. Question 6. Oh, you can see the symmetry is here because you've got the 7, 7. Because it's a negative quadratic. 4, x equals 4. 1 plus, so that's 1 plus 20 minus 16. That's 5. When x is 6, x equals 6. That's 1 plus 30 minus 36. That's minus 5. Well, symmetry might not be here actually, but let's just see. When x equals 1, 1 plus 5 is 6 minus 1 is 5. No, I think it is. And that's going to be minus 5 if you work it out. So we just plot those points. Let's start with minus 1 minus 5. Now you know it's a negative quadratic, so it's going to be the sad face. And I'm just going to plot these points quickly. Okay, so those points are plotted. Remember a smooth curve. Smooth curve. This is going to be hard to do on my tablet, so do bear with me. Key tip here, can you see these lines? Do not do a straight line here, that would be incorrect because it's a sad face. So if you just do a little curve, that will be enough. You could lose a mark if you just make it a straight line. And this is a very nice start to the paper. You're definitely going to get some lots of marks again right there. Okay, students always lose marks on this. What does this mean? That means 5x y squared times 5x y squared times 5x y squared. So you do multiply the powers, but you have to cube this 5, which is what people always seem to forget to do. So that's 125 x cubed y to the power 6. Triple brackets, that should be a banker. I would expand the easiest one first. So that's going to give me 2x squared plus 3x. So you can see that. Plus 4x plus 6. So that's going to be 2x squared plus 7x plus 6, and I'm going to multiply it by the final bracket. So 2x squared times x is going to be 2x cubed minus 14x squared plus 7x squared minus 49x Yep, that's good so far. And the last one, 6x plus 6x and minus 42. We're going to simplify those terms. There's a 2x cubed minus 14 plus 7x squared, that's minus 7x squared, minus 49 plus 6, that's minus 43x, minus 42. Do have your working, because students do lose a mark on these negative symbols. That should be banker, 3 out of 3 really, guys. Okay, so this is a nice paper. 9, find the equation for L. So remember the song Y, MCA, well it's Y equals mx plus c in maths. M is the gradient. C is the y-intercept. So we've got c equals -1 here. That could get you a method mark. Let's find the gradient. The scales are the same, so that's nice. It's going downhill, so the gradient's going to be negative. People do make that mistake of not realising that and use it as a positive 2. So it's going, so that's going down 2, and that's 1. So m equals -2. That's just y equals -2x minus 1. Question 10, histograms. Histograms seem to always appear. Do pause these videos as I go along and try the questions yourself sometimes. Alright, the histogram shows information about the ages of all the passengers travelling on the plane. No one on the plane is older than 80 years. Okay, we can see that. 24 on the plane aged between 40 and 60 years. So that's bar's worth 24. So we've just got to think, if that bar's worth 24, frequency density is the frequency divided by the class width. So here the frequency is 24. That bar is worth 24. Divided by the width is 20 equals the frequency density. And that equals 1.2. How could you work that out easy? Well, that's just because that's going to simplify to 12 over 10, right? That's 1.2. So this scale on the side must be like this, going up in ones, because that makes 1.2 there. Work out the total passengers on the train. Well, so this one is going to be 0.4 times 10. That's 4. This is 1.8 times 10. So you've got 18. 4 here. That's 6.4. So 6.4 times 5. That's 30, 32. That's exactly 2 times 15. Let's do it working. 2 times 15. Get your mathematics 30. And that's 0.8 times 20. That's 16. Add those numbers up together. So 4 add 8 plus 32 plus 30 plus 24 plus 16, and that equals 124. 124 people on the plane. The passenger on the plane is picked at random. Work out an estimate for the probability that this person is older than 55 years. Let's look at 55 years. So we've got 16 here. Got to work out this amount here then, right? So that's 1.2 times 5. That's the frequency density, that times the, not times 5, times 10. No, that is 5. From here to here is 5. And you can see that's 1.2. So 1.2 times 5 equals 6. add the 16 people. 6 add 16 equals 22. And how many people on the plane? 124. That is a doable histogram question. Question 11, cumulative frequency. They've done it cumulatively. On a graph, draw that. So you just plot the endpoints and the frequency, guys. So you should plot 6 at 40. And it starts at 30, so do not make it join up to 0, that would be incorrect. So 40 is 6, that's 10, 40 is 6 here. Let's just do one more point for you. 50 is 20. Okay, so I plotted those points. Oh, this graph does not start at 0, so that's fine. So remember, smooth line here. Okay, that's how we do that. That's a bank of 2 marks in your pocket. Use your graph to find an estimate for the median length of time that these adults went for a walk. So how many adults were there? 100, so we go to 50. Do your dotted line, that is actually worth a mark. Do a dotted line down with your ruler. That looks like 59 to me. They all accept a range. And their range they accept is 58 to 59. One of the 100 adults is chosen at random. Use your graph to find an estimate for the probability that this adult went for a walk for more than 72 minutes. So 72 is here. Let's do a better dotted line than me. I'm going to say that's in between. That's 80, that's 90, 86. So I'm going to say it's 87 people. That's 87 here. So that means 100 minus 87 is, it's from here to here, more than 72 minutes. It's this part of the people. So that's 100 minus 87 equals 13 people. So I'll say it's 13 out of 100. Okay, that's worth 3 marks, and your method marks will be writing that and your line on the graph, or using your graph. So the simultaneous equations, so this is quadratic simultaneous equations, guys, and you would just substitute this. They've helped you out here, you don't need to rearrange it, into swap the 2x plus 1 for the y squared. I mean, so essentially all this question means is there's a quadratic like this, there's a straight line like this, and you're going to find these 2 points by using algebra. So we sub the 2x plus 1 for the y here. So what we're going to get is, I'm going to start up here because it's going to take a lot of space, plus 3 times 2x plus 1 squared equals 5. So the first thing we want to do is work out this. So let's go over here. That's 3 times 4x squared plus 4x plus 1. That's this expanded, equals 5. Expand that all out. show clear algebraic working. Okay, that's nice. Let's combine the like terms. 14x squared plus 12x. I'm going to minus 5 here, minus 5 as well. Minus 2 equals 0. Right, this is all divisible by 2, so we'll make it easier on ourselves to factorise and use the quadratic formula. Hopefully this can be factorised. If you're not good at factorising, just use the quadratic formula. That is correct up to there. You could actually do this by inspection, because you know 7 is prime. It's got to be this, right? You're going to have a 1, but you've got a plus 6. So that's got to be plus 1 here. And minus 1. Expand that, that will equal that. So you have to solve this. So x equals 1 over 7. So make that 0 and x equals minus 1. Right, we do need to have to find the y values for that. So when x equals 1 over 7, what is y going to equal? Y equals, that's 2 over 7, subbing into here, plus 1. 1 is 7 over 7, so that's going to y equals 9 over 7. And x equals minus 1, y equals minus 1. So you do need to pair these correctly for good form. I'm just going to see if they've done that. So yes, so you pair these together. So when I could write it like this. Or just write it as a coordinate. That should be acceptable. Because that would be the coordinates where they meet. But writing it paired together like that is fine as well. If you write this x paired with that y, that would be incorrect. Oh, that's a nice 5 marks. Make m the subject. Right. So we're going to multiply both sides by 2m minus y. We get p squared 2m minus y equals x plus m. Let's expand that out. So we're going to get, just going to write the 2m here. And let's write the 2m here. 2mp squared minus yp squared equals x plus m. We want all the m's on one side, so I'm going to minus m and minus m because we're making m the subject. We can get m on both sides, get them all on one side, and then factorise. So you get 2mp squared minus m. Now I'm going to jump a step and plus this yp squared over equals x plus yp squared. Factorise this out, take the m out, so you're going to get 2p squared minus 1 and then you divide out by your 2p squared minus 1. Which will leave us with m equals x plus yp squared divided by 2p squared minus 1. That is normally you write this in alphabetical order, so that should be p squared y as in good form, but you should still get the marks for that. I mean, you should 100% get the marks for that. I just wrote this like this so you get the p squareds at the end. Okay. Oh, this looks like perpendicular lines. Now, remember, it's y equals mx plus c, not 2y equals mx plus c. So we'll divide that by 2 to get that to y equals 3x minus 2.5. L2 is perpendicular, so essentially you've got a line like this, and you've got a line going here that crosses at 9 minus 1. So we know m equals 3, so, and that's we call m1. So the perpendicular gradient is going to be minus 1 over 3. It says give your answer in this form, so do that. That was going to be work with a mark. So let's substitute that into y equals mx plus c. So we're going to get y equals minus 1 over third x minus 2.5. We have this coordinate 9 and minus 1 here. Let's sub that in. So minus 1 is going to equal 9 times minus a third is minus 3. And that's not minus 2.5, that is plus c. Okay, because that's the new line. So that's minus 3 plus c. So we're going to plus 3 on both sides. And we're going to get c equals 2. So this line here, L2, is going to be y equals minus a third x plus 2. And you're going to get a mark for finding out c, a mark for finding the perpendicular gradient. How many marks is this worth? 4. You'll get a mark for writing this, but is it in this form? Is c on its own? No, it isn't. So we need to multiply everything by 3 to cancel out this fraction. So then we get 3y equals minus x plus 6 plus the x over. So 3y plus x equals 6 for your final answer mark. Yep, that's a nice full marker there. 15 now. A curve has this equation. There's only one maximum point on the curve. The maximum point is this. So if it's a maximum point, it could be a graph like this. And they're saying that is 4, 3. So this is graph transformations. So remember, when it's inside the bracket, we solve. We solve, and inside impacts the x coordinate. X, so that means x is plus 5 here. So that means x is going to move to the right 5. So 4 add 5 is 9, and that will be 3. That's on the outside. If it's on the outside bracket, impacts the y coordinate. So we just, that's 3 there, so when it's the outside we multiply by 3, so what's the y? 3 times 3, that's 9, 4 stays the same. Nice. Well, this is a really nice paper. Boundaries will be high on this. Okay, so this is a functions type question, and g of x is just x minus 5. There's been an error in the conversion. Okay, so it says state which value of x must be excluded from any domain of the function f. So this is a function, obviously it's a type of graph. So what will not be included in this graph? Because it says excluded. So what value of x won't fit it? Well, we know anything divided by 0 would be infinity, right? Or they sometimes call it undefined, because you cannot define this on a graph. So we need to solve 4x minus 3 equals 0. So that means 4x equals 3. So x equals 3 over 4. And that's the answer. When x equals 3 over 4, we're going to get 3 over 4 divided by 0. And that is it. Find fg of x. So we've got x minus 5 is g of x. We swap that into f of x, so fg of x equals x minus 5, that gets swapped for the x, and x minus 5 gets swapped for the x next to the 4, put that in a bracket, minus 3, so that's going to equal expanded x minus 5, that's 4x. You're going to get a minus 20 here, minus 3, minus 23. Simplify your answer. I think that is simplified because I've expanded out the bracket. So functions is really easy to get good marks on. Express the inverse function. So just write that down here. Express the inverse function f minus 1 in the form of f minus 1x. Right. So what is f of x? Again, x for x minus 3. So remember when I said you do inverse, just put y in, make x the subject, so we're going to multiply out by 4x minus 3 on both sides. Let's expand that out. So we're going to get 4xy minus 3y equals x. We're almost there. Get all the x terms together on one side, so we're going to minus x on both sides. And I'm going to bring this 3y over, so that's going to turn that to positive 3y. We factorise this here, so we just take the x out. That's 4y minus 1 equals 3y. Then we know we divide out by 4y minus 1. So we get x equals 3y divided by 4y minus 1. And we just replace the x with the y now. So the answer will be 3x 4x minus 1. Well, that's a nice 3 marks. Right, find an estimate for the gradient of the curve at the point where x equals minus 0.5. X equals minus 0.5 here. So essentially, you draw a tangent, show you're working clearly. This is non-calc. So I hope this is a good line. I'm going from here to here. Okay, I'm going to extend my line. Just so I can deal with whole numbers, because this is a non-calculator, so we can see this length is 3. And that goes from 5 to 23, right? So that's 18. It's positive, so we're going to get 18 over 3 equals 6. And that is an acceptable answer. Nice work here. Question 17. Right, this is going to be a little tricky because you haven't come across something like this before. But what do we know about powers, okay? What do we know? We know that when you divide powers, you will subtract, right? But the bases aren't the same. So how can we make the bases the same? So I'm going to say 3n equals 3 to the x over 3 times 3 to the power of y. So hopefully you can see what's happening here, right? Right, I think explaining it like this is going to make sense to you. And it's in terms of x and y. So n, we've got to write in terms of x and y. So this is going to be 3x. Imagine this is going to be now 3y times 3y. This is the same thing. Okay. Now, can you see what happens here? We add these powers when we multiply. That's going to be 3x. We add the powers. So that's going to be 3 to the 2y. Now the rules of indices. So remember, if you had something like 3 to the 7 divided by 3 to the 5, that equals 3 to the 7 minus 5, for example. Okay. So just because there's letters, if we simplify 3x over 3 to the 2y, that's just going to be 3x minus 2y. Okay, so now we've got 3n equals 3x minus 2y. So can you see what matches? N must equal this. So n equals x minus 2y. That is tricky for a lot of students. Unless you see something like that appear, you won't know how to apply your skills to do that. So hopefully that's going to help you out a bit. Question 18. This is a nice probability one. Have a read of that. So there's 4 marbles in the box, the rest of the marbles are yellow. So we don't know how many are yellow. But just say, should I use n? Let's call n is the number of yellow. N equals yellow marbles, the number of yellow marbles. Okay, number. So, and we know 4 of the marbles are red, so 4 are red. We're going to keep that. So if you think about it, the total amount of marbles is going to be n plus the 4 red ones. Okay, that's a key point. So Antonia takes at random a marble from the box and does not replace it. Sergio then takes a marble from the random marble for the box. The probability that Antonia and Sergio both take a yellow marble is 0.7. Okay, so if we were to draw a tree, what's the probability of picking yellow? First, that's P yellow. Well, we know it's going to be N, that's the number of yellow marbles, plus the total number of marbles is N plus 4. Right, red is going to be 4 over N plus 4. But we don't need this information yet. So yellow again is going to be 1. There's 1 yes yellow in the box because you've taken a N. So then that means you're going to have N minus 1 marbles out of, remember there's 1 less marble in the whole box. So that's got to be N plus 3. Okay, and we know that that probability P yellow yellow equals 0.7. So what we're going to write is N over N plus 4 times N minus 1 times N plus 3 equals 0.7. Right, we're going to multiply out to simplify this. We want to get rid of this M. So as we're multiplying, that's just going to be N times N minus 1, N plus 4, N plus 3 equals 0.7. So we're going to multiply both sides by N plus 4, N plus 3, okay? Plus N plus 3. So we're going to just expand that out. Get 0.7. Let's expand this as well. N squared minus N. That's going to be N squared plus 7N plus 12. I do not like this 0.7. 0.7 is 7 over 10, right? So if I multiply both sides by 10, we're going to get 10n squared minus 10n equals 7n squared plus 7n plus 12. Let's expand that all out. So we're going to get 7n squared plus 49n plus 84 equals 10n squared minus 10n. Now we want to solve this, so it's a quadratic. Let's set it to 0. So let's move everything about. So I want to minus 7n squared on both sides to get 3n squared minus the 49n, so we're going to get minus 59n and minus the 84 equals 0. Now I don't think we can simplify that anymore. Now is that factorizable? Well, we're going to have something times 3 times 84. Those factors are going to be difficult to find to make 59. So let's have a think about that. Right, so if in doubt, use a quadratic formula. It might be easier to do this. Okay. If you can't factorise. But it's a non-calculator paper, so you should be You might find it hard to do the factors when you do 3 times 84, but I'm going to do this because we know one of these numbers has to be 3n and n to get the 3n squared. How are we going to get 84 and 59? I'm just going to do the factors of 84, which is 2 and 42. One of those got to be minus 4 and 21. That looks like we can do something with that. 4 times 21. So 21 times 3, if I put the 21 here, is 63. 63 minus 4 is going to give us that. That's perfect. So the 21, I think that's got to be minus, and that's the plus. Yes. If you expand that, that will be correct. So the solution to this, well, n is the number of, equals number of, let's say number of yellow marbles, right? Is it about marbles, this question? I think so, from what I remember. So you can see here, n's got to equal 21. Or n is going to equal minus 4 over 3. Which we know that can't be correct. So n must equal 21. So the number of yellow marbles must be 21. Yep. What's it asking? And then we know that there's 4 red marbles. So n 21 plus 4 is 25, right? So the answer is 25. Oh, there's a big 5 mark. So it is worth practicing these because that's going to help you get your grade 8 or 9. And these are doable. It's just algebra. Question 15. Right, this is completing the square. This is completing the square with a coefficient. So I'm just going to write it this way. Minus 2x squared. That's plus 12x plus 5. That's just easier for me to work it out. Remember, we take the minus 2 out. Then we're going to get x squared plus, oh, but that's a minus there, minus on the outside, so that's got to be a minus 6x and plus 5. So this bit makes this bit, and we keep the plus 5. Now we can complete the square here. Just didn't like that dot. So let's just complete the square here. We know this bracket, let's keep the minus 2 on the outside, is x minus 3 all squared. Now this is still in the bracket, guys, because we're doing that. That's going to give us a plus 9 at the end when we expand, so we've got to include the minus 9, so this here equals exactly that, and we've got the plus 5 on the outside. Right, so next step is to expand that out. So what we're going to get is minus 2 x minus 3 squared. That's actually going to minus 2 times minus 9 is going to give us a plus 18. I'm going to take that out of the bracket now, but keep this there, plus the 5. So we're going to get minus 2x minus 3 squared plus 23. Now I don't want that in this form, so we're going to say it's 23 minus 2x minus 3 squared. Yeah, a, b and c are all integers, and you can leave the answer exactly like that. And remember, we did do that in class. Oh, that's worth 4 marks. That is doable, but I can see that lots of students will forget how to do this, because that's quite a high level completing a square with a coefficient. Oh, I really feel you can get a grade 8, guys. Okay. Right, it's a graph of sine. Now, this is going to help. This is obviously a transformed graph, okay? So, in blue, I'm going to just draw the graph of sine x. So we know sine 90 equals 1. Right, so this is a normal sine graph. It's a bit more stretched out than normal. So we're going to think, I'm going to change colour pens. Right, how is this point being transformed up here? So, reminder, outside the bracket changes the y coordinate. Inside bracket changes or affects the x. The x coordinate. Okay. But it's the inverse we solve. So first step is, let's see what's happened to y. That has been transformed up there. That's been doubled, outside exactly the same, so a must be 2. Okay, so that point matches that point. Now let's see the next dip. Can you see this is the next dip? That's the first dip, second dip. Let's just use this. That looks like that maps there. That's up here. Now, how can I explain? Okay, this is perhaps a bit easier. It affects x. Can you see this first? That goes from 0 to 180, right? This is worth 60 here. That's 60. So this, the original one, is 3 times bigger. So if it's 3 times bigger than b, so from here to here, b must be 3, because when it's wider, this is narrower, so it's going to squash the x coordinate, so b's got to be 3. Okay, but worth putting a guess here for getting 1 mark, right? Because you could even guess a mark here. No working out required. And I've just got to double check something. Oh, and A is not 2, so I would have lost the mark, because this point doesn't match with this, does it? That's the first dip is here. So you can see 1 times minus 2 must be that, and this point matches that point. Okay, so A is minus 2. Oh, I would have lost the mark on that, I think, in the real conditions. Question 20. Okay, so this means 1 times 2 divided by 2. So term or sequence is 1, 2 is 3, term 3 is 6, term 4 is 10, term 5 is 15, term 6, 42 divided by 2 is 21. 2, 3. Maybe I can do it this way. So you can see that's going up in 2, 3, because you're showing them the squared numbers, plus 4, so it's going to be a quadratic type sequence, plus 6. Okay, so second difference is plus 1, so we know 2a equals 1. Right, it's going to be an squared plus bn plus c, so a equals a half. Let's try it this way, and then we've got b, we've got 3a plus b must equal this plus 2 equals 2, so half b equals a half. Now what does c equal? Now c equals a plus b plus c, which equals 1, so c equals 0 here. Right, this might be a roundabout way of doing this. So I mean, a plus b plus c must equal this first term here. That's half. So this as a quadratic sequence will be n squared, or half n squared plus a half n. That's the quadratic sequence. And now we're going to prove that the sum of two consecutive terms of this sequence is always a squared number. So let's, like, n equals 1 term. So when n equals 1, so we're going to get, n plus n plus 1. That's what we're trying to prove is a squared number. Okay. So let's whack it into here. So when n is it, we're going to get a half n squared plus a half n, and let's do the next term, plus a half n plus 1 squared, so that's n plus 1 plus a half n plus 1. So what's this going to be here? This bit is going to be n squared plus 2n plus 1, and that's a half. That's in a bracket, half n plus 1. Okay. Let's expand that all out. So we're going to get a half n squared plus a half n plus a half n squared, half times 20 is plus n, plus a half, plus a half n, half times 1 is a half, plus a half, right, can you see that's a 1 there? Let's do a bracket here. Okay, let's simplify that. That's going to give us n squared. A half n, you've got a half n, add a half n. That's plus 2n. And we've got a half plus a half is plus 1. Right. So this is the sum of any two numbers, consecutive numbers. Sum of consecutive numbers for this sequence. Now you need to recognise that this is actually just n plus 1 squared, right? So that means must be a squared number. That's your proof. That is a tricky 4-mark proof. Lots of skills there.